Welcome back to Max with RP. Today we are going to look particular kind of integrals and how a specific technique helps us to resolve such integral of such functions. So we are going to learn how to integrate functions of this type dx by x power 4 plus 1. I'm going to use a particular technique. So I'll call this as I equal to dx by x power 4 plus 1. I'm going to multiply and divide by 2. And rewrite this as half into x square plus 1 by x power 4 plus 1 minus half into integral of x square minus 1 by x power plus 1 dx. I split it as two integrals. See, this is x square minus x square. It gets cancelled. 1 minus of minus 1 will be plus 1. So 1 plus 1 will be 2. Half is outside. Half into 2, that 2 I have split as 1 plus 1, added and subtracted x square. Now we will write this as first integral minus second integral. So what I am going to do is, if I have x minus 1 by x as t, I know that 1 plus 1 by x square dx will be dt. So I am going to divide by x square. This I am going to rewrite it as half into integral of 1 plus 1 by x square dx by x square plus 1 by x square minus half into integral of 1 minus 1 by x square dx by x square plus 1 by x square. So 1 plus 1 by x square is the derivative of x minus 1 by x. So I have to write this one in terms of x minus 1 by x. 1 minus 1 by x square is a derivative of 1 plus x plus 1 by x. So I'll rewrite this in terms of x plus 1 by x. So now I'm going to rewrite this as integral of, what is the first one? I'm going to rewrite this as half into 1 plus 1 by x square dx by x square plus 1 by x square. I'm going to write it as x minus 1 by x the whole square plus 2. Why am I writing like this? Please understand, 1 plus 1 by x square is a derivative of x minus 1 by x. That is why I am writing the denominator in terms of x minus 1 by x. Whereas in the second integral, this is half into integral of 1 minus 1 by x square is the integral of x plus 1 by x. So I will rewrite this as 1 minus 1 by x square dx. Denominator will be x minus 1 by x plus 1 by x the whole square minus 2. Now, if I take u as x minus 1 by x, du will be 1 plus 1 by x square. If I take t as x plus 1 by x, dt will be 1 minus 1 by x square. So this is the technique we are using because it helps us to resolve the integral in terms of known integrals of known functions. This is half into, if I take this denominator, this as u, then I'll get u square plus 2. Du is 1 plus 1 by x square dx. So this is du. If t is x plus 1 by x, dt will be 1 minus 1 by x square dx. So minus half into dt by t square minus 2. Now this is of the form x square plus a square, where a square is 2, so a is root 2. The second integral is of the form x square minus a square, where a square is 2, so which is a is root 2. And we also know the formula, recall, integral of dx by x square plus a square is 1 by a tan inverse x by a. Integral of dx by x square minus a square is 1 by 2a log mod x minus a by x plus a plus c, constant of integration. This is something we have seen, derived and used to solve problems in the earlier video. So now I am going to use the same formula here. Accordingly, this will be 1 by 2 into 1 by a 1 by root 2 tan inverse u by root 2. This is minus 1 by 2 into 1 by 2a 2 root 2 log mod t minus root 2 by t, x minus a by x plus a. Here instead of x I have t. If a square is 2, so a is root 2. Now I have to substitute for u and t. This will be 1 by 2 root 2 tan inverse x minus 1 by x by root 2 minus 1 by 4 root 2 log mod x plus 1 by x minus root 2 by x plus 1 by x plus root 2 plus c. So this is a particular kind of technique. Whenever you have functions in the denominator which involves x power 4, this technique of multiplying, dividing by 2, adding and subtracting x square will help us to build it into 2 as a difference of 2 integrals which can be resolved because we know how to integrate functions of these types. So we are reducing it to functions of these types. Let us look at a similar problem. Look at this function. Here also in the denominator we have x power 4. So I am also again going to use a similar technique. Okay. So I will be equal to integral of, I am going to divide by x square. So what will I get? 1 by 1 plus 3 by x square dx. Denominator is x square plus 9 by x square plus 10. I have divided every term by x square. So x square will become 1 plus 3 by x square. Denominator becomes x square. First I have written this 9. 9 by x square plus 10 x square by x square is 10. Now, this is a derivative of what? Suppose I take, let u be equal to x minus 3 by x. Then what will be du? Derivative of x is 1 minus, what is the derivative of minus 1 by x plus 1 by x square? So 1 plus 3 by x square dx. So if I write u as x minus 3 by x, then du will be 1 plus 3 by x square dx. Now, what will be the denominator? Denominator is what? X square plus 9 by x square plus 10. This can be further written as in terms of u. So x minus 3 by x, the whole square. What is this? X square plus 9 by x square minus 6. So I have to add 6, which will give me 16. This includes minus 6. So I am adding 6. Already there is 10. So 10 plus 6 is 16. So the integral will now be equal to integral of, what is 1 plus 3 by x square dx du? What is the denominator? U square plus 4 square. U square plus 16, which is u square plus 4 square. Now this is of the form dx by x square plus a square. What is the formula? 1 by a tan inverse x by a. So this will be 1 by 4 tan inverse u by 4 plus c. This is 1 by 4 tan inverse x minus 3 by x by 4 plus c. 1 by 4 tan inverse x minus 3 by x by 4 plus c. Are you able to follow? So I am using same type of techniques to solve such problems. Now look at this, x square dx by x power 4 plus 1. So I can write I as half into same technique 2x square dx by x power 4 plus 1. This can be further written as half into x square plus 1 by x power 4 plus 1 minus half into integral of x square minus 1 by x power 4 plus 1 dx. So look at the numerator, x square minus x square plus 1 plus 1 2. Sorry, should be plus half into x square plus 1 by x power 4 plus 1, half into x square minus 1 by x power 4 plus 1. Half x square plus half x square, half into x square plus x square, which is 2x square. Plus 1 minus 1 will get cancelled. Now this can be further written as half into 1 plus 1 by x square dividing by x square. Then how should I write the denominator? The derivative has to involve 1 plus 1 by x square. The denominator I should be able to write it as, first of all I have to divide by x square, then I will write x square plus 1 by x square plus half into 1 minus 1 by x square dx x square plus 1 by x square. So what I have done? I have multiplied divided by 2. 2x square split as x square plus x square, added and subtracted 1. Now I split the entire integral as a sum of two integrals. For the first one, the derivative should be 1 plus 1 by x square dx. So I should write the denominator in terms of x minus 1 by x. For the second integral, the derivative should be of the form 1 minus 1 by x square dx. So the denominator should include function of the form x plus 1 by x. So I am going to write this as half into integral of 1 plus 1 by x square dx by x minus 1 by x the whole square. It involves minus 2. So I am adding 2 plus half into integral of 1 minus 1 by x square dx. This is the derivative of x plus 1 by x the whole x plus 1 by x. So I'll write the denominator as x plus 1 by x the whole square. It includes 2. So I have to subtract 2. This will be half into, if I write u as x minus 1 by x, du will be 1 plus 1 by x square dx. So this becomes du by u square plus 2 plus half into, if I write t as x plus 1 by x, dt will be 1 minus 1 by x square dx. So this will be dt by t square minus 2, which is half into x square plus a square. How will you integrate? 1 by a tan inverse x by a. So 1 by root 2 tan inverse u by root 2 plus 1 by 2 into 1 by 2a, 1 by 2 root 2 log mod t minus root 2 by t plus root 2 plus c. Now I have to substitute for u and t. This is 1 by 2 root 2 tan inverse, what is u? X minus 1 by x by root 2 plus 1 by 4 root 2 log mod t is x plus 1 by x minus root 2 by x plus 1 by x plus root 2 plus c. So we have seen three difficult integrals, 1 by x power 4 plus 1, then x square by x power 4 plus 1. We also saw how to integrate function of the type x square plus 3 dx by x power 4 plus 10 x square plus 9. All the three problems shared a common technique. So which is what I've used in all the three problems. When should I use the technique? Whenever the denominator involves x power 4, then that particular technique of dividing by x square is going to help us to resolve the problem. So I hope you understood the technique, and I hope you are able to practice more problems until you become confident about this technique. So until we meet next time, it's goodbye from Maths with RP.